Hey everybody, it's Mr. Oaks. So I'm making a follow-up video to the exponent properties video that I did last time. This is more exponent properties. So there's two other properties we want to talk about. The first one is called the zero property of exponents. This is a really simple one, but what I want to do is I actually want to kind of show what happens and how it comes up. So if you look, I have here that x to the 0 equals 1. Basically, the zero property of exponents says any number to the 0 power except for 0 is going to equal 1. So the question becomes, how does this happen? So there's two ways I can show. So the first way I'm going to show is through this table, because I'm going to use this to show the second property that we're going to talk about as well. So I have here 2 to the 4th is 2 times 2 times 2 times 2 gives us 16. 2 to the 3rd, 2 times 2 times 2 gives us 8. 2 to the 2nd is just 2 times 2, which equals 4. And then we get to 2 to the 1st, which is just 2. I'm going to write that there. So what you see is every time we drop the exponent down by 1, the exponent decreases by 1, we're getting rid of one factor. So 2 to the 4th, we have 4 2's. 2 to the 3rd, we have 3 2's. 2 to the 2nd, we have 2 2's. 2 to the 1st, only 1 2. But the thing I notice over here is that every time I'm taking a 2 out, I'm dividing my previous answer by 2. So, a little bit off. So to go from here to here, I'm going to divide by 2. To go from 8 to 4, we're going to divide by 2. To go from 4 to 2, we're going to divide by 2. So then the question becomes, well, 2 to the 0, I can't write anything here. There's nothing to write. I don't know what to write. So I have to figure out what to do. Well, I'm going to follow this pattern that I have here. I'm going to keep dividing by 2. And when I divide 2 by 2, I get that 2 to the 0 is equal to 1. The other way we can show this is, let's say I have 2 to the 3rd divided by 2 to the 3rd. I'm going to show two ways with this as well. What I can do is I can expand this. So on the top I can have 2 times 2 times 2. On the bottom, same deal, 2 times 2 times 2. And what happens is I can cross out. So 2 on top, 2 on bottom. So 1, 2 on top, 2 on bottom. That's a 1. 2 on top, 2 on bottom. So all of them cross out, and we're left with 1. There's two other things I can think about, is that when I have a number divided by itself, it's going to be 1. So 2 to the 3rd divided by 2 to the 3rd is going to be 1. The other thing is to use one of the other properties we did, the quotient property, which said that when I have two numbers with the same base dividing each other, I'm going to subtract the exponents. So here, I would do 2 to the 3 minus 3, and that's going to give me 2 to the 0. So if I know that over here it equals 1, and over here I show that my exponent will be 0, then 2 to the 0 must be 1. And this will work with any number, any variables, even pictures. They sometimes throw pictures in there. It's kind of weird. But basically, anything to the 0 power is going to equal 1 with the exception of 0. So I have 4 problems here. Honestly, they're the easiest thing. 8 to the 0. Oh gee, what's that going to be? Guess what? It's going to be 1. Oh, well here's a negative 7 to the 0. Oh gee, I wonder what that's going to be 1. Here's a fraction. Oh, that's a small number. I got to put that to 0. Guess what? It's going to be 1. Here's a really big number, 34,621 to the 0 power. Guess what? That's going to be 1. X to the 0 is always 1. X to the 0 is always 1. Anything to the 0 is 1. I could write race car and put it to the 0 power. It's going to equal 1. Okay? It's going to equal 1 every single time. My wife right now is behind the computer laughing because she thinks I look like a fool. And I do. Okay, so 0 exponent property, easy. If something's to the 0 power, it's going to equal 1. Now we have a thing with the negative exponent property. Yeah, there's going to be negative exponents. So the general thing, and I'm introducing that first, but you'll see. X to the negative n, so some number to a negative power is going to equal 1 over that number to the positive version of that power. Alright? Basically, we're going to wind up with what's called a reciprocal. If you remember, reciprocal is when we take something and we flip it. Usually it's referring to fractions. And I know everybody loves fractions. Yay. Okay? So, I'm going to go back to my little chart here. So each time we were going, alright, we reduced our exponent by 1, we noticed that we divided by 2 over here. So I've gone 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0. So now I'm going to take my exponent and subtract another 1. Well, 0 minus 1 is going to be a negative 1. And what I'm going to do over here, I'm going to divide by 2. Alright, that's my pattern. I got to continue this pattern. So when I do 1 divided by 2, I get the fraction 1 over 2, which this is actually 2 to the 1. Alright, 2 to the first power. So it's 1 over 2 to the first power. Went from having a negative exponent to having a positive exponent. Let's do another one. So I'm going to subtract again. Negative 1 minus 1, going more negative. We get 2 to the negative 2. Going to divide again by 2 over here. That looks like a Z. Alright? But when we take 1/2 and divide it by 2, we get 1 over 4, which is the same as 1 over 2 to the second power. So we're, again, 2 to the negative 2, our answer, we have the total here, but our answer is 1 over 2 to the positive 2. So we go from a negative exponent to a positive exponent because we made it a fraction. We did the reciprocal. So let's take a look at these 4 problems. Alright? The way this works, again, like if I was to use something, say, I'm going to use, say, 4 to the 3rd divided by 4 to the 7th, 4 to the 7th. What I can do is I can rewrite this like a fraction, 4 to the 3rd over 4 to the 7th, and then I can expand this. So So along the top I have 4 times 4 times 4. Along the bottom, 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5, 4 times 4. I can do the canceling out thing again. This is purple. So I have this 4 and this 4. Those cancel out to 1s. I have this 4 and this 4. Those cancel out to 1s. This 4 and this 4 cancel out to 1s. I have no more 4s across the top. So when I multiply that, I get a 1. Along the bottom, I still have 1, 2, 3, 4 4s. So I can rewrite that as the exponent 1 over 4 to the 4th. So that's my positive version. This, if I was to rewrite it, I can also write as 4 to the negative 4th. Because I'm doing 3 minus 7. I'm doing a smaller number subtracting a bigger number. I'm going to get a negative answer. So that's how that kind of works. Now obviously you shouldn't have to do all this work. That's a lot of stuff to show for every single problem. So that's why we're going to still use kind of this subtraction if we have something like this. But then we have to take into account if it's a negative exponent. Most of the time we want to write the expression using positive exponents. So here, 5 to the 2nd divided by 5 to the 6th. What I'm going to do, I'm going to do the subtraction. 5 to the 2 minus 6 gives me 5 to the negative 4. I want this, I'm just not seeing that negative. Alright? I want this as a positive exponent, so I need to rewrite it. 1 over, my base is 5. The positive version of negative 4 is going to be a positive 4. This is one of those that gets a little, you can get a little tricky because not only are you dealing with fractions, you got negatives, it's all the things you guys love. Here, less stuff to do. We don't have that division issue there. But 7 to the negative 5. That negative tells me that I have to do the reciprocal of this. So I'm going to do 1 over, my base is 7, and I'm just going to change the exponent from a negative 5 to a positive 5. That's it. Then we get some of these, where they get a little fancy. They get a little mean. I'm going to actually lift this up a little bit so we can see a little bit better. This says 1 over 3 to the negative 2. So now we have the negative in the denominator of a fraction. Remember, when we see the negative, what we're really thinking about is we're going to do the reciprocal. Well, since this is already 1 over, when I flip that, it's going to become 3 over 1, or just 3. And again, change the negative that we have here to a positive, and we get 3 squared. One more. 1 over 9 to the negative 4. Again, the negative is in the denominator, so what we have in the denominator, we're actually going to move up to the numerator. We're going to move on top. So now it's no longer 1 over 9 to the negative 4. It's going to be 9. Change the negative exponent now to a positive. 9 to the 4th. Okay? Negative exponents are tough. 0 exponent is ridiculously easy. Really, if you have difficulty, these are the ones, the negative exponents, those are the ones you really got to try your best with. You really got to work at to really get comfortable with and understand them. Alright, I hope that this is helpful. If you have questions, please put them in the comment section, or if you're one of my students, message me. Just These are tough things, and it's important for you to understand them. Alright? Hope everybody's good. I've been Mr. Oaks. Have a good one.